Section 2.6, dealing with transformations. So last video we looked at the basic graphs, and now we need to figure out how to shift them, stretch them, compress them, and reflect them. So let's talk about translations. Translations, another thing we call those is shifts, and we can have translations that are vertical or horizontal. In other words, move the graph up and down or left and right. So when we talk about translations, we're going to be looking for addition and subtraction in our equations. So if we have addition inside the function, that is going to shift our graph to the left. If we have subtraction inside our function, it is going to shift the graph to the right. So if we have addition outside the function, we are going to shift our graph up. If we have subtraction outside the function, we are going to shift our graph down. So look for adding and subtracting, and they are going to shift the entire graph up or down or left or right. So what we want to do with a translation is move the starting point, and then we're going to follow the pattern to get the rest of the graph that goes with that function. So here's an example. I have y equals x plus 3. So that is inside the function because it's added before we square. And what I need to remember is that it's the opposite to the sign. So if I have addition inside, that is going to shift my graph left. If I have subtraction inside, it is going to shift my graph right. So here this says x plus 3, which is going to shift my graph left by 3. So originally on y equals x squared, the start point was at 0, 0. But if I shift my graph left 3, then I have to subtract 3 from my x, so my new starting point is at -3, 0. So instead of my graph starting at 0, 0, I'm going to shift it over to -3, 0, right there. And then I'm going to use the pattern, over 1, up 1, over 2, up 4, left 1, up 1, left 2, up 4, to get the rest of my graph. So starting from my new start point, go over 1 and up 1, put a dot. Go back to the start point, over 2, up 4, put another dot. Then to the start point, left 1, up 1, back to the start point, left 2, up 4, and then, well, if I get that in the right spot, this will be what my new graph looks like. If I have y equals x minus 3 squared, then that is going to shift my graph to the right 3. So I take my normal start point, y equals x squared starts at 0, 0. Shifting right 3 means I need to add to my x coordinate. So then I'm going to have my new start point at 3, 0, and then use the regular pattern. Right 1, up 1, right 2, up 4, left 1, up 1, left 2, up 4. So that graph would go to a start point at 3, 0, right there. And then I follow the regular pattern. Go to the start point, go right 1, up 1, go back to the start point, go right 2, up 4. Back to the start, left 1, up 1, back to the start, left 2, up 4, and that gives me my new parabola. Y equals x squared plus 3 shifts the graph up 3. When I shift up 3, I'm going to add to my y's. When I shift down, I'm going to subtract from my y's. So my normal start point is 0, 0. I'm going to add 3 to my y, so my new start point will be 0, 3. 1, 2, 3. Put a dot there. And then follow the normal pattern. right 1, up 1, right 2, up 4, left 1, up 1, left 2, up 4. So from the start point, go right 1, up 1. Back to the start point, go right 2, up 4. Back to the start point, left 1, up 1. Back to the start point, left 2, up 4. And that's what my new graph looks like. X squared minus 3 shifts my graph down 3. So from my normal start point 0, 0, I have to subtract 3 from my y. So that's going to be at 0, negative 3. And then I'm just going to follow my pattern. Normal pattern, go right 1, up 1. Go back to the start, go right 2, up 4. Back to the start, left 1, up 1. Back to the start, left 2, up 4. And then that is what our graph looks like. Now notice that after the transformations, sometimes our domain and range will change and sometimes they won't. So you're just going to have to, after you move your graph, look at it and get your new domain and range. So I've given you some examples of what each of the basic functions look like when they are shifted up 8, which means we add 8 to our y, and that's what it looks like for each of the basic functions. This is what it looks like when we shift down 8, so we will subtract from our y coordinate of our start point. This is what they all look like when they are shifted left by 8 and when they are shifted right by 8. So refer back to this until you get used to until you get used to what they look like, whether they are left, right, up, or down. All right, stretches and compressions. With a stretch and compression, we are going to be looking for multiplication either inside or outside. And whether it's inside the function or outside is going to tell us if it's a vertical stretch or a horizontal stretch or compression. So we're looking for multiplication out in front makes a vertical stretch and compression. Inside the function, we're looking for multiplication in front of the x for horizontal stretches and compressions. So here's what that looks like. This is outside the function. This is inside the function. This is outside, inside. Outside the square root, inside the square root. Outside absolute value, inside absolute value. So you're going to look to see whether your multiplication is inside or outside to be able to know if it's a vertical or horizontal stretch or compression. Okay, for a vertical stretch or compression, what we're going to do is multiply the number by the ups and downs in the pattern. So if you have a vertical stretch and compression, multiply the number by the ups and downs in the pattern. For a horizontal stretch and compression, you're going to flip the number and multiply that by the lefts and rights in the pattern. So we will practice this. Here we have y equals 3x squared. So this is going to be a vertical stretch by 3. So what I need to do is multiply the ups in my pattern by that 3. So let me write down the pattern for y equals x squared. Remember, the pattern for y equals x squared was right 1, up 1, right 2, up 4, and then left 1, up 1, left 2, up 4. That's what made the parabola. So if I have this 3 out in front, what I need to do is multiply the ups by 3. This one doesn't have any downs, so I'm just going to multiply the ups by 3. So 3 times the ups. So instead of over 1, up 1, I'm going to go over 1, up 3. Instead of over 2, up 4, I have to multiply that by 3, so over 2, up 12. Instead of left 1, up 1, I'm going to go left 1, up 1 times 3, which is 3. And instead of left 2, up 4, I'm going to go left 2 and up 12. If I have 1/3 out in front, I'm going to take all of my ups times 1/3. So I have over 1, up 1 times 1/3, which is 1/3. Oops, I meant to go right 1. Right 1, up 1/3. Right 2, up 4 times 1/3, which is 4/3. And then left 1, up 1/3, left 2, up 4/3. So what this does to our shape is if I'm multiplying all my ups by 3, the graph gets taller and skinnier. But if I'm multiplying all my ups by 1/3, all of my points get shorter and squattier. So we call this kind a vertical stretch and this kind a vertical compression. So a vertical stretch is going to be when this number out in front is bigger than 1. A vertical compression is going to be when that number is between 0 and 1. So it makes everything shorter. Then these ones are on the inside. So that's going to be a horizontal stretch and compression. What I need to do is flip the number and multiply that by the lefts and rights in the patterns. So remember that these guys are my lefts and rights. Left and right. These guys are my ups and downs. So when this number is inside, I'm going to flip the number over. So I'm flipping over 1/3 and making it 3. And I'm going to multiply that by my lefts and rights. So I take my right 1, but I need to do times 3. So right 3, up 1. I don't do anything to my ups. Right 2 times 3, which is 6, and then up 4. And then I do the same thing to the lefts. Left 3, up 1, left 6, up 4. So what that's going to do to the graph, instead of going 1 and 1, 2 and 4, I'm going to go to the right 3 before I go up 1. And then I'm going to go to the right 6 before I go up 4. And I go the same way the other way. So to the left 3, up 1. And then to the left 6 before I go up 4. So this one does this shape. Well, that point got a little far out of the way. It does this shape. So this is called a horizontal stretch, because what I did was took my graph and stretched it out this way. And then if I have 3x and then squared, I have to flip that number to make it 1/3 and multiply that by my lefts and rights. So instead of going to the right 1, I go to the right 1/3 before I go up 1. Instead of going to the right 2, I go to the right 2/3 before I go up 4. So this is actually going to make my graph very, very skinny, because here's 1. So if I'm only going up, if I'm only going right 1/3 before I go up 1, that's right here. And then I'm only going right 2/3 before I go up 4, that's right there. And then I do the same thing left ways. So left 1/3, up 1, left 2/3, up 4. So left 1/3, up 1, left 2/3, up 4, makes that graph super tall and skinny. So what I did was I squished it horizontally. So that is called a horizontal compression. Horizontal compressions happen when your number is between 0 and 1. Horizontal stretches happen when your number is, horizontal compressions happen when your number is bigger than 1. Horizontal stretches happen when your number inside is between 0 and 1. I have a really nice graphic on the next page, so we'll look at that here in a second. Right here. If the number that is multiplied on the outside is bigger than 1, you have a vertical stretch. If the number that is multiplied on the outside is between 0 and 1, you have a vertical compression. If the number multiplied on the inside is bigger than 1, it's a horizontal compression. And if the number multiplied on the inside is between 0 and 1, it's a horizontal stretch. But what happens if that number is negative? Well, that makes it a reflection. Reflections are always going to have a negative multiplied. So reflections, we are looking for a negative that is multiplied. It could be just a negative, like a -1, or it could be like a -2 or a -3/4, any of those. If the negative is out front, so if your negative is out front, then you will reflect over the x-axis. And the way you do that is by switching the ups and downs. So all your ups turn to downs, all your downs turn to ups. If the negative is inside the pattern, you will reflect over the y-axis, and you do that by switching the lefts and rights in the pattern. Basically, these are always attached to stretches and compressions. So I have the other end of the spectrum here. If your number is negative, then you're going to reflect across an axis. If your number is positive, the graph is not going to flip. So here's what it looks like. If you're reflecting across the x-axis, which means you switch your ups and downs, then the number will be out in front. But if you're reflecting across the y-axis, which switches your lefts and rights, the number will be inside the parent function or basic function equation. So here, we're going to do this with square root because the squaring one isn't too exciting. So on a square root, remember that the pattern for a square root is that we start at 0, 0, then we go right 1, up 1, right 4, up 2, right 9, up 3. So here we have a reflect on the outside, so that is going to be over the x-axis. So what I need to do in that case is switch my ups and downs. So I'm going to go right 1, down 1, right 4, down 2, right 9, down 3. So that is going to take this graph starting at 0, 0, going right 1, down 1, right 4, down 2, and it's going to make the graph look like that. But if the negative is on the inside, then I'm reflecting across the y-axis as such, which means I need to switch my lefts and rights. So my pattern is going to, I better write that down, reflect over y-axis. So I'm going to switch lefts and rights. So instead of going right 1, up 1, I go left 1, up 1, and then left 4, up 2, left 9, up 3. So what that does to my graph is I start at 0, 0, go left 1, up 1, start at 0, go back to 0, 0, go left 4, up 2, and that makes my graph reflect across the y-axis. If you're looking at negative x squared, remember the pattern for the x squared graph was right 1, up 1, right 2, up 4, left 1, up 1, left 2, up 4. So this reflects across the x-axis. When you reflect across the x-axis, you switch your ups and downs. So I am going to now go right 1, down 1, right 2, down 4, left 1, down 1, left 2, down 4. So this graph goes from 0, 0, right 1, down 1, back to 0, 0, right 2, down 4, left 1, down 1, left 2, down 4. So that will make my graph go that direction. But if I reflect over the y-axis, so that I switch my lefts and rights, now I'm going to go left 1, up 1, left 2, up 4, and right 1, up 1, right 2, up 4. That is not going to do a whole lot to change my graph. Left 1, up 1, left 2, up 4, and right 1, up 1, right 2, up 4 did not change the appearance of my graph at all. Most of the time, however, you are going to have more than one transformation in a problem. So we are going to come back and do another video where we talk about what order to do those transformations in and get some practice with them.